So last time we were talking about functions. And what are functions? So functions we described as basically like a box or a container that has some code inside. And that box has the ability to maybe take some inputs, do some processing, and then perhaps produce some output. I don't have the box today, so I'll just describe it. Can you guys see this, or is this too thin? It's too thin? Okay, then forget it. Okay. So we talked about a box. Well, how do we describe this box, this container where we put some code in a program? Well, in JavaScript, we do it as follows. So these boxes are known as functions, right? So we write the word function, and then we define a hole, which is where we're going to push the inputs through, right? So this is the hole right here. And if we want this function to take certain values through that hole, those values need to be named so that they can be used within the function. So we need names for the values that are going to get pushed into that hole. Fair? So let's create a function, a simple one, that will simply add two numbers together and return the result. So what do we need as input to add numbers together? The numbers. And a plus or a summation typically happens between two values, right? You take this value and you add them together. So we need two arguments in this case. So let's name our arguments. Let's name the values that we will get. So let's call it num1 and num2. Okay. And in the body, that is to say between this guy and this guy, in here is where we will implement our code. The code that will run when the box is executed, when the function is executed. So let's go ahead and say, well, what would be the code for adding numbers? Yeah, so it's num1 plus num2. That will add them together. So whoever said it, just wait 1 second. For everyone else, what will happen if this function runs right now? Yeah, it will add the numbers together. And that's it, right? But what we want is this function to then push a value, a result from the other hole, right? Once we have the inputs coming in through this hole, we want the result to go out of the other side. Yes? So the way to push something out of the other side, this return. Imagine return written on my leg, okay? So that is known as return. Okay, so we are pushing, returning n1 plus n2, num1 plus num2. Okay, so then we take this function and we put it into a variable. Now remember, variables have names, right? They're names for things. They're names for values. What would be a good name for this function? Sum or add, sure. Let's call it add, just to keep it simple. Right. Remember, it's important to have a name that describes the value, right? If we called this, imagine we called this minus. You think people will get confused? Yeah. So naming really matters, right? Also, if I called it z, means, okay. And then later, you see something like, z, and you go, wait, what the crap is that? I don't know what that means. Do you know what, right? So, but if we call it correctly, if we call it sum, and then we execute the function, we run the box, yeah? We run the box by passing to it through this hole, a 2 and a 3, 2 being num1, 3 being num2, and then remember, the other side it will num1 plus num2, which would be 2 plus 3, 5. So the result of this would be 5. This thing runs and returns 5.
And we don't need to write constant result?
Okay. If I just said 5, is that useful for your code? No, it's a value. You want to do something with that. Maybe you want to put it into a variable, const r. Maybe you want to print it, console.log, r. You can do with it whatever you want. You have the value, now you decide what you want to do with that value.
No, I mean here in the function, we need to write constant result or return is enough.
Ah, okay, so what you're asking about is this. Could we just do this, or could we could also do, create some variable like const, I don't know, call it whatever you want, boros. Oh my god, you guys. Boros. Sorry. And then you can return boros. Do you see how it's exactly the same thing? Yeah, correct. Oh, Netherlands. Thank you. Right. You guys see that it's the same thing, right? In one case, you're taking the value, giving it a name, and returning it the name, which is the value, same thing. In another case, you're just, okay, watch. Forget sum. Const, func, or runc. Func, function that takes no arguments and returns a 1. It's not a very useful function, but it's, if you call it, it will return a 1, right? This runs and turns into, that. This turns into that. So if I do const r is equal to func plus func minus func, okay, well this runs and turns into 1. This runs and turns into 1. This runs and turns into 1. This runs and turns into 2. This runs and turns into 1. And r now has 1. So if I were to then console.log r, I will get 1. You see how execution works? Okay, so now that you understand this, let's add some arguments to func. Const func, yes, I did just rewrite that for no reason. Let's say it takes an argument like a, whatever, not a very good name, but just as an example. And then we call func with, say, a 3. And all it's going to do is return a. Okay, so we do const r is equal to func3 plus func4 minus func5. Well, func3 will call a is 3. It will return a, which is 3, and therefore this will compile to 3. Right? It will execute and turn into 3. This will execute and turn into, and this one? 5. And then this one will add together, giving me 7. And then this will run, giving me 2. And now r has 2. Make sense? Okay, so now let's do something more interesting. Instead of just taking an a, let's give it an a and a b, and let's return the result of adding a plus b. Now if I do func 1 and 2, this will turn into 3. Make sense? Okay, now let's do a longer equation. Const r is that plus func 4 and 5 minus, no, actually that's enough. 1 and 2 get added together, you get 3, plus func gets run, right? 4 and 5 is 9. 9 is added to 3, and you get 12. Making sense? Good. Now let's do something a bit more involved. Now, let's make a bunch of mathematical functions that we can then use to compose more interesting mathematical functions. So first, let's do add. Const add is a function that takes what? Yeah, num1 or num. You can write number or num, whatever, as long as it's easy to understand when you read it, right? Okay, and it's going to return num1 plus num2. Cool. How about a minus? Help me implement a minus function. Go. Yeah. Return. Because remember, we need, right? That's the return. Return. Good. Okay, so we have an add, a remove or minus, whatever. Let's do like 2 more. Maybe multiply, divide. What do you think? Yeah? Okay, so const mult. Mult? Yeah, fine. Go. All right. You know what? Who cares about divide? Fine. This is good. Okay. Okay, now, fine. Const func. Which will return, let's see, add 1. What will this turn into? Okay, so let's break up the vi. So this func, when you call it, you go here, num1 this becomes 3, this becomes 4, right? From here, you then call add with a num1, which is a 3, and num2, which is a 4. What is the result of calling add with a 3 and a 4? 7. Okay. Then what is the result of running this function? 93. Return is the, so the thing that pops out of this function is, make sense? Yeah. So this thing that we just did here, this is called function composition. What do we mean by composition? You're composing. You're taking existing things and you're sticking them together to make a newer, more interesting thing, right? So I took a basic function like add and minus, and I combined them together to make a more complicated function. Remember what I mentioned about systems. Systems, even the most complicated ones, are made of small, simple parts. In terms of functions, think of it that way. You have simple functions that combine together to make more interesting and complicated functions that can then be used to make more complicated functions, etc., etc. Let's do that. So we have this function that seems to subtract from 100 the addition of these two numbers, right? Let me create another function, const func2, that will take a single number, num1, and what it will do is it will return the result. No, first it will make a variable, r. It will call func with num1 and an 8. It will then const r2 minus 100 and the result of r. It will then R3 multiply, okay, mult times 0, no. Okay, multiply times 2, how about? Not very lovely. 2. And then it will return whatever R3 is. Okay, so you guys know these functions. I don't think I need to keep them around, right? You can just do this. This is the part that matters. Okay, then I call func2 with a 2, just to keep it simple. Okay, go. $20. I got a 20. I got a xan. 20? Anything else? Okay, let's actually go through the execution in our heads, right? In Chechen. We'll see. Look. So first thing we do is we call this box func2 with a 2. So 2 goes in here and num1 becomes 2. Yes? So this is a 2. So that means this is a 2. Right? Agreed? Okay. So we call this with a 2. What happens when you call func with a 2 and an 8? Well, let's go. So 2 goes here, 8 goes here. So 2 is this and 8 is that. 2 plus 8 is 100 minus 10 is 90, and that is returned. So the result of this is, yes? Now, r, which is 90, minus is 10. So this result is 10. Then R2 goes in here, which is 10. Multiply 10 times 2 and you get 20. So R3 has 20. And then you return R3, which of course is 20. And so the result of this function is 20. Is what? Sorry? Is that clear? Yeah? Is it unclear to anyone? I want to make sure. This is really important. Okay, so here's what's cool about programming. So this step-by-step execution that we did in our heads, right? We were solving this execution. We were running the execution like we're the processor. We were going through it one step at a time, right? Just now. There's a tool that you can use that will help you do this. It's called a debugger. This is really important. Watch this. Let me put everything back to the way it was. There. And let's use a tool called a debugger. First, what is a debugger? A debugger is something that allows you to go through the execution of your code one step at a time. That way you can see what's happening in your program, right? Where can I use a debugger? Well, you guys are using Chrome, I'm guessing, right? If you're not, please do. If you are, watch. You right-click and you go to Inspect. Okay? When you click on that, you get this Development Tools. This is your console, right? This is where you get your messages. Yes? We talked about this. There is another one called Sources. This is where you can see the code that is loaded into Chrome. Now what you want to do is you want to tell the browser that is running your code to stop somewhere. To stop somewhere, to pause, so that you can begin going step by step. That place where you say stop here is called a breakpoint. A breakpoint. How can we make a breakpoint? In JavaScript, you can make a breakpoint by simply writing the word debugger. Huh, look what happened here. Let's open it up a bit. Let me make it a bit bigger. Can you guys read this? In the back? You want me to make it bigger? Make it bigger. Better? Okay. So this is the code I wrote. Notice how this line is highlighted. The execution has stopped at line 2, where the debugger is, where the breakpoint is. I can then use this arrow to say next. Next, next, next. Look what happened here. It tells me the variables that were created. The add variable, the minus variable, and the mult variable. And what are the values? Well, they're functions. Look, f implies function that take as argument num1, num2. Minus is a function that takes num1, num2. Etc., etc. Now, let me hit next. Now I have a func. Now I have a func2. Now what I want to do is go into this function. I want to go into the box. I've given the box a 2, but I want to go with the 2. Okay? Look, you have the box. I was throwing in the 2 and taking the result, right? If I want to go into the box to look around and see what's happening, I have to go in. Yes? In In is this. Step into the function. You press that, you're now in the function. What is the value of num? There it is. It says it. It's 2. Look, this 2 went here, and now num is 2. Right? Let's go into func. Again, the down arrow. We're now inside of func. Num1 is 2. Num2 is 8. We are then going to call add and then minus. Let's go in. We're now inside of add. We're adding 2 and 8. So 2 will be added to 8, the result of which, and now we go into the minus. So now minus takes the 100 and the result of adding 8 and 2. And then we do subtraction there. And we come out of there. And now we can see that R is 90. Okay, so now when you see minus, you know that R is 90, right? So you're saying 100 minus 90. Let's step into that. So it's 100 minus 90, which is 10, right? So when we get out of this, R2 is 10. Cool, okay. So then we say mult R2, which is 10, times 2. 10 times 2 is 20. If I don't want to go into the equation, to the function, I do this. Boom. And now I know R3 is 20. If I want to go into the box, I do this. If I want to just get the result of the box, I do this one. Get it? Okay, so now R3 is 20, which is in fact the result of calling func2 with a 2. Kind of cool, right? This debugger will save you. There are two kinds of errors that you will typically see when you're writing your programs. There are syntax errors. Syntax errors means you just wrote something incorrectly. Grammatically, you did something wrong in the code. Like you forgot to put a parentheses, or you added an extra comma or whatever. You wrote something wrong. Those are pretty easy to find because it says which number the error is on. You go and you go, oh, oops, I did that, and you fix it, no problem. A much harder issue is when your program works, but it works incorrectly. That is the harder problem. That is a logical error. The way to solve logical errors is to use a debugger, because you're going through every step and then you're going, wait, that shouldn't, that's where I made the mistake, and you go and you fix it. Make sense? Okay. So we'll be using this debugger to go over code from now on. So instead of me just saying this is going to turn into 20 whatever, we'll let the debugger show us. It will make it much easier, and I want you guys to start using this debugger. It's very important that you learn to use this tool. It will save you. Okay. Now let's write a function that's a bit more useful. So one mathematical operator that we have not discussed yet is called the modulo operator. It looks like this. Like that. It's a percent sign. It takes the remainder of dividing the two numbers. Okay? So you take the two numbers, the number on this side, let's say 10, the number on this side, which is say 2, and you take the remainder. Now 2 is evenly divisible into 10, and so the remainder for that would be 0, right? So you guys get what it does, right? Okay, so let's write a function that will take a number and tell us if the number is even or odd. Fair? Okay, so let's go from the beginning. I need a variable. Go. Huh? Is even. Okay, so is even, implies that it's going to return a yes or a no, right? A Boolean. By the way, as a naming convention, if you see is anywhere, like if a variable name begins with is, it probably has a Boolean result, right? Is male will return true if it's male, false if female. Is legal, is whatever, it's going to say yes or no, right? So whenever you have a function that returns a yes or a no, it's a good idea to lead with is. It just makes sense that way, okay? So is even will return Presumably true if it is even or false if it's not. If I wrote is odd, it would work the other way. Yes? Okay, so is even. We're going to put inside of it. How do we put something inside? Equals, good. And then whatever I put now will go into that variable. So we want to make a box. What is a box? Function. We need a hole. Let's open the hole. It needs to take a value to then decide whether that value is even or not, right? Well, what kind of value is it? Yeah, it's a number, right? So maybe it makes sense to name a variable accordingly. So let's call it num. Okay, and then we want to check to see if it's even. So how can we do that? Using maybe the modulo? If, fine. Modulo 2 is equal 0, Okay, so I'm hearing two different things. One is let's console log the result. That is to say, just print the result to the console. I've also heard let's return a Boolean. Is even is expected to tell you if something is even, right? I want to know. I don't want you to go right. Console, think of the console as the whiteboard. I come to you and I say, you know, how old are you? And instead of telling me, you go over there and write on the board. It's weird. I just asked you a question, right? Tell me, right? If I ask you, can you please go write on the, okay, then go, right? But if I'm asking you a question, you know, it'd be nice if you told me the answer, yes? Same thing here. Don't just go writing on the board. If I tell you now, then after calling is even with, say, you know, 99, then write that result to the console, or write it on the board, if you will. Okay, fine. But this should not be writing on the board. This should do what the name says it does. If the name says, you know, print if is even, okay, then print. Sure, write on the board. But it doesn't say that. It says is even. I'm expecting an answer. Is it even? Yes or no? Huh? Okay, so back to this. So if it's evenly divisible, that is to say there is no remainder, the remainder is 0, is it even?
Yes.
Right. So saying true doesn't mean enough. We have to push something on the other side, right? So we have to push true out of the hole. If that's not the case, we can do else. Right, we have to push false out of that hole. Right? Okay, not bad. So let's test our function. So is even 99 is false, 100 true, not bad. How about 2? Nice. How about that? Okay, how about this? Okay, how about that? Okay. Ah, it works. Yes. We Intra? 0. Let's try it. And what about negative numbers? So negative numbers work. Yes? Ah, okay, so watch this. What is 0? Is it truthy or falsy? So one thing you could, so if falsy, if will not execute, if truthy, if will execute, right? So that means what we could do is actually get rid of this, but now if it's falsy, then else will run, right? Because if it's 0, this will run, right? And then, so we could do it that way. We could also, if that's a little weird, we could not, exactly, we could not this expression. That is to say, if it's 0, flip it, make it true. And then return true here, return false there. Does that make sense? Okay, let's optimize this even more now. What will this expression return? A Boolean. What Boolean? True or false. If it's evenly divisible, that is to say, if this returns a 0, which is falsy, doing this will do what to it? A Boolean value, which is true. Interesting. Now that you know this, help me turn this into one line of code. What if I were to instead just do highly? Very cool. Watch. If this number was 100, the remainder would be 0, right? So this would turn into 0. 0 is falsy, yes? So it's here. It's not here, that's false, it's here. Not returns a Boolean value, which is the opposite of what you gave it, yes? So what is the opposite Boolean value of this? True. So if it's 0, that is to say there is no remainder, and you flip it, you get true. That means it's evenly divisible. True, yes. In the other case, if you have a remainder, it's truthy, it's here. If you flip it, you get false. So it's not evenly divisible, therefore it's not even. Hast du gesagt? Yeah? Okay, so now you know this. Help me implement is odd. Go. Sorry, 1 sec. Not, then what? Num modulo, where's modulo 2. Okay, let me turn this back into what it was, num modulo 2. Not bad. John. So one of the things that I want you guys to learn to do is don't rewrite code, okay? The logic for understanding whether something is even or not has already been implemented. Why are we implementing it again? Let's reuse the other box that we already made that already knows if something is even. Let's call is even with a num. This will tell us if it's even, but what we want to do is if it's even, then it's not odd, right? So we have to flip it. Function composition. We are composing a function using other functions. Make sense now? Does it not make sense to anyone? It's okay? Jen. Okay. All right, let's do this then. Let's have a function that doesn't take a value, returns boros. We have another one, const f2, which, again, bad names, right? F and f2, it's not good names, but just as an example. Function, okay, and we return bedros, following the same pattern. We then have a const full name function that takes a first name and a last name and returns the full name. What can I write to return the full name? Like that? Why? Why is this not a good idea? What's the result of this? Right. assuming the inputs are boros bedros, right? Right, okay, so let's tell you what. For now, let's leave it. We'll see the problem, then we'll fix it, yeah? Just bear with me. Okay, so we have a full name. Now let's call full name and pass it as an argument the result of calling f, and then the result of calling f2. Now let's console log, that is to say, call the log function with the result of calling all of this stuff. Şuna kalsın. Can. Okay, so look at this. So the result of calling this turns into what this returns, which is boros. F2 running it will return bedros. So we have boros, comma, bedros being passed into full name. So full name gets boros and bedros. Boros gets, the characters boros get combined with bedros. And what you get is boros bedros. Right? Everyone see that? Right, so what might make sense is to instead add a space. So what is this here? It's a string, which has one character in it. This is a character. It's a space character, right? Okay, so we added a space character between the two values. And remember, the plus operator is overloaded. If it has a string on either side, what does it do? Sticks them together. What is the proper term for sticking things together? Concat. It concatenates them together. Remember that word, concatenate. Yeah? It means sticking text together. So it concatenates fname with an empty text, and then that result is concatenated with lname, and the result is bedros space boros. Let's concatenate that with is so cool. Now we get bedros boros, boros bedros is so cool. Okay. Again, by the way, notice how I've called this function with the result of calling this function and the result of calling that function. Let's do some more interesting things. Let's const, f3, which takes some string, stir, and returns stir plus is really awesome. Then what we do is we call f3 with the result of calling full name, which we call with f2, and then f. Yeah. What does that return? Okay, so let's break it down. So what we get is bedros boros is so cool, is really awesome. Okay, so let's break this down. F2, when it runs, what happens? This turns into bedros, right? What happens when you run F? Okay, what happens when you run full name over bedros boros? Right, John, exactly. You get space is so cool. Yeah. And then what happens when you run F3 with bedros boros is so cool? You get bedros boros is so cool, space is really awesome. And so the result of that would be is really awesome.
And why do we need that function str?
It's not a, str is not a function. What is str? Yeah, but what is it? It's a variable. What is it? What variable? It's the name of the thing I'm pushing into the hole. Think of it this way, guys, look. Okay, you're sitting here, and I'm asking you guys to compute the area of a triangle, right? I send you a message saying compute the area of a triangle. I have to tell you what the base is and what the height is, right? Yes? Okay, so in the message I say the base is this, the thing is that. So I need a name for the value. I say the base is this, the height is that. I need a name for each value. You then take the names and go, oh, it's not 43. 43 is the base. 52 is the height, and then you run your equation. Now, it's true that for a triangle, it actually doesn't matter what order you give it, right? Because multiply, you get the same result either way. That's not a problem. But you can, I'm sure, see lots of situations where it does matter, the order in which you get it, right? Like concatenating first name and last name. Boros Bedros is different from Bedros Boros, right? So the order in which I pass arguments matters because they go into the corresponding variable names. That's why when I call this guy, Boros and Bedros, Boros goes here, Bedros goes here. If I call the same thing with Bedros Boros, you get Bedros here, Boros there. Jokes? Yeah, okay. Questions so far? Okay, not bad at all. I think we're doing pretty well, actually. Okay, so the question is, can we just, when we call it, instead of just calling, like basically with a list of arguments, like 1, 5, 10, if we can say like base is 1, height is 10, blah, 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 right? That's what you're saying? Yes, but I'll tell you later. Later. Yes, but you have to know a few other things. Go.
If we declare function that like const name equals function, can we call the function before declaring it? Or?
Good question. Okay, so very good question. Look, he's saying this. So we have a function like f. And then here we have, it takes some argument like foo. And then it, returns foo plus 1, whatever. We know that if we call f with 15, what is the result of running this function? 16. Right. The question is, can we do this? Right. So, okay, so let's not talk about the other thing that we talked about later. Consider this. Let's put this aside for a moment, and let's look at this. Const a is 1. Here we understand that a is the same thing as 1. Yes? So I can do console.log a plus 2. And a is now 1, so 1 plus 2 is 3. That's intuitive, yes? Is that intuitive? Why? The variable has not even been created yet, right? Remember, code executes like this, right? So we start from the so forget the function stuff for now. Forget this. It starts from the top and it goes down, and it sees A. What the crap is A? We've never seen A. We don't know what A is. Error, right? This way, though, okay, it makes sense. It says A is a variable. Inside of A, we're putting 1. Fine. Later, when it says A, it goes, oh, it's the variable. We know about it, and we know it has a 1. It puts in a 1. 1 plus 2 is 3. Everything is good. Yes? It's the same thing. Exactly the same thing. Just like you're putting a 1 into an A, here, we're putting a function into F. Same rules apply. If you see F, you don't know what it is. Here, you see F, you know what it is because there it is. John. Great question. More questions. Go, go, go. Okay, no questions. Fine. Yes, sir.
Are there any pre-written functions by the creators of
Lots, yes. And we will get to them very soon. Yeah, yes.
So what's the possibility that we name a function and that is already created?
It's possible. That's called collision, right? So you're colliding with someone. You're overriding something accidentally.
But will it work? Like if you write a function with a name that already exists, will it will yours work or the other?
Okay, so functions are very often attached to objects. You don't know what an object is yet, so exactly. So it's rare that you just have a global function with the same name, and if so, then you might end up overriding it. If they used const and you used const and it's in the same part, that's an error actually. You can't create a variable with the same name using const. Eto kosak. Okay. Okay, bye. Okay, so at this point, I hope, let me check the time. Okay, so at this point, I hope you guys have a pretty good understanding of functions, right? They're this packaged code that can run, it can possibly take an input and do something, and it can possibly return something or do something else. An example, again, of not returning something is console log. It doesn't return anything, it just goes and writes on the board. The board, in this case, being the console. Yes? We understand this. Good. Let's talk about variables. There's a notion of scope. Variable scoping. What do we mean by scope? Scope is the part of the code where you can read that variable. Okay, so what do I mean by this? If you guys are in the other room and I come here and I make a box and I put a 1 in it. If you guys are in the other room, can you see the box? No. I can see the box because I'm in this room. But you can't see it because you're in the other. That is called scoping. Scope. It's the part of the code that can see the variable that has been created. Kind of get it so far? Let's see what we mean by that in practice. So suppose I were to make a variable here, const, r1, and put an 8 there. Oh, I'm sorry. Thank you. Const. Okay. I made a variable called r1, and I put an 8 inside. You see this thing here, that like curly start and stop? Think of that as a room. Things outside of that room cannot see it. If I am here somewhere, am I inside that room or not? No, I'm outside that room, right? So I cannot read R1. I don't have access to R1. I can make my own R1, const R1, and put whatever I want into it. Sure, no problem. But I can't read R1. R1 is closed, encapsulated in the room. I can't access it from the outside of the room. With me? But here's something interesting. Here I can make a variable, which I can put a 1 in. Yes, and I can use that in my equation. Yes, no problem there. Nothing new there. Yes? I put a 1 in there. What if I put a box in there? That's okay. And have that return a 3. And then call that box. So this will turn into a 3, and then 3 plus 1. Oop, I have to call it, f. And then I have to give it a value. Let's say, I don't know, say a 9. And then I don't see anything. Why? Nothing is drawing on the board. Nothing is drawing to the console. So I call the function to do that. Log is the function that will draw it. And I get a 4. Interesting. Why did I get a 4? I passed a 9 in here.
Because it doesn't take values.
Yeah, foo is not even used. Look, foo is 9, but it returns calling a, which is 3, plus 1, which is 4. It doesn't even use foo. That's okay. But notice something interesting here. What I've done is I've made a function inside of my function. I made a box inside of my box. Matroshka. Why don't I make a function inside of this function? Why not? Const b is a function. And have that return an 8. Why not? And then here we can call b plus 7 there to get a 15. Then we get 1, and we get 16. So what happens here? This calls f, so we end up in this guy. foo being 9. We create this function, and then we call that function with no arguments. That goes in here. Actually, why don't we use a tool? What's the name of a tool we can use to step through our code? Debugger. And let's begin our debugging. Let's start our debugging, pause our code right here, because this is where the interesting stuff begins. So put a debugger. This is right-click inspect. I'm putting it there so to mess you up. Okay, so we hit next to go to the next line. Now we want to go into f. What is f? It's a function, it's a box. We want to go into the box. How do we go in? The down arrow, right? The in. Okay, now we're in here. Foo you see is 9. We make a. So now a is just a function. And then we call a. Well, I want to see what's happening inside of a. I want to go into a. Down again. Now I'm in a. It makes a b. I want to go into b. Okay. It returns 8, right? So then 8 plus 7 is the result of that. And we get blah 16. Sort of see that? Okay, now here's an interesting thing. Notice this foo. Remember how I said you can see the box if you're in the room? Imagine if we made a smaller room inside of this room. You're still in the room, right? You're in a small like sub room, but you're still inside that room, right? That means you can still see the box. Interesting. So that means from here, instead of returning 8, let's return num. Now you might say, wait, what? But this room, this box right here that was made doesn't have a num. Num was never made in that box. True. Here's what you do. Pay attention to this. You first check to see, does the variable exist? That is to say, has it been created inside of my box? Do I have a local variable with that name? Is a num made anywhere in here? Yes or no? No. So what you do is you go up 1. Think of it this way. You go out of your room into the room outside of you. You go out 1. So you go out, so you go into this room here. Is a num made in this area? No. So you go out into the next room, which is this room. Sorry, I wrote num. Sorry. Does foo exist here? No. Does foo exist there? No. Does foo exist in this part? There it is. Foo. And what value does foo have? 9. This 9 goes into this foo, and then that goes into there. So what is the result of running this code?
16.
Yeah, I knew that. You guys see why? Let's break it down. So you call f with a 9, so so foo is 9, right? You call a, you go in here, blah, blah, blah. You do b, b returns foo, which is 9. So this turns into 9. 9 plus 7 is 16. And then, so therefore this becomes 16. Therefore this becomes 17. And voila, you get 17. Oops. You guys getting this? Yes, sir.
Why we have to do that? Do we create a function inside the other one, although we can use another approach?
It's just, I'm giving you tools. You can use them however you like. If you can use a wrench as a hammer, but you might say, wait, I don't want to use a wrench as a hammer. I want to use a hammer as a hammer. I'm just giving you tools. How you will actually compose and use the tools is up to you. Got it? So the knowing that you can make a function inside of a function is a tool. In some contexts, it makes sense to do that. In others, it does not. Okay? It depends on the... We'll see situations where it makes sense. I'll show you some situations. Yeah? Yes?
So if you create a variable inside the curly braces,
Inside the room.
you can create the variable with the same name outside of the
Yes. You can also make... So think of it this way. Every room can have its own variables with the same name. In other words, if I... Look, let me create a variable here, const b, and put in, 4. Sorry, let me get rid of this stuff and have this one just return. This is too confusing. Wait, let me give you a new example so it's clear. Const f is a function. And inside of it, we have a variable called const b, which is 5. Out here, we have a variable const b, which is 6. We then make a function here, const, which is a function. Here I have a variable, const b, which is 9. And then here I just do console.log b. And let me call f2. And here let me call f. And I get a 9. Let's see what happens. When I call f, I go into this code here. Right? So it makes a b, it makes a function, it calls the function, we go inside of this block. It makes a b, which is a 9, I come here and I console log b. First question, does a b exist in my room?
Yes.
There it is. So it prints that, which is 9. Now, does a b exist in my room? Go one up. Go outside of your room to the next room outside of you. You end up here. This is the room outside of you, right? That's the next block. Therefore, you are here now. You have b, which is 5, so you print b. If I get rid of that one, go one up from that, and you end up in this scope. Remember, room, scope. Don't say room. Room means scope. Yeah? So now substitute this idea of room with scope. When I say scope, I mean that. I mean one of those rooms. This is known as the global scope. It's the outermost room. It's the biggest, it's the room that everything else is inside of. Am I right? No, I'm not right. You guys get that? This is known as the global scope, or the global room. You can think of it that way, but say scope. Global room. I wonder if there are bathrooms. Okay. Global scope. Okay, but notice one thing though. Let's go to the original. That each room can have its own set of variables with the same names. That's okay. So, I'm sorry, did I answer your question? Yes? What else? Okay, so let's repeat this one more time. If you are not in the room, you cannot see the variable. If you are not in the scope, you cannot see it. If you are in any given scope and you see a reference to a variable, try to find that variable inside of that scope, above, of course, that line, right? Go up from that line and see if it's declared in that scope. If you cannot find it, go one out. Go up one. Out of your room into the next room. Into the enclosing room. Into the enclosing scope. Find a variable there. If you find it, use it. If not, keep going. If you keep going and it does not exist, it does not exist there, it does not exist there, it does not exist there. That is an error. Because what is A? It's saying, I couldn't find anything that has A, and you're trying to use A. What the hell are you doing? Error. That's why nothing printed. It didn't print undefined. It said no. Make sense? Yes?
Will it still go out of the room is when the B is under?
Interesting question. So I've never actually tried that. So here's what he's saying. This is really interesting. Let's go back. So let's do this. My guess, so before we look, I'm going to guess. I'm going to guess that it's going to give 5, yeah. But let's see, I don't know. I honestly don't know. Ooh, it's an error. Interesting, because of this confusion. It's saying, wait, you're trying to refer to a B. Ah, I know why. I understand why. Sorry, okay, it's coming to me. The reason why it's saying this is it's saying in the scope, a variable is made, but it's made after you made it. And because of this rule, this is illegal. Remember the rule I was explaining to you where you have, because of that rule, this breaks. So the answer to your question, this is why I didn't know, because you can't do it. So you're not allowed to do that. Yeah, fair? Very awesome question. I love it. That was great. More questions? Yes, sir.
How to say that if, for example, we make a constants, many constants, like how to say that if you do not find any constant in any rule, for example, say there are no constants.
There is an error.
Yeah, that how to not print anything, but to print that there is an error.
Okay, so you can use, come see me after that. There's a try-catch block. I don't want to teach that here. I will come after, I'll show you. Just remember, try-catch. You can Google it, try-catch. Basically what you do is you wrap your code around this with this thing, and any error that happens calls this piece of code that you then do whatever you want. Okay? Yes? I think I step.
Is variable and const B returns blank. Error. I did return beyond name.
In true?
Okay.
Okay. Let's. So first of all, no, because there it is. You can see the 5 it prints. So let's. Okay. So there's some confusion. Let's clear that up. Look. We call f. We go here. We create a variable called b. We put a 5 into that. No problem. We create a function. We create a variable called f2. We put a function into that. No problem. We then print b. Does B exist in this scope?
Yes.
Where is it? Right there. So we print 5. We then call F2. F2 goes in here, creates a variable with a 9, and returns a B. Returns 9.
F2 becomes 9.
Right. F2 becomes 9, yes. That happens, basically. Exactly. I don't see any problem with that. Let's get started. Good. Other questions?
Can we make an infinite loop?
Yeah, once we're doing recursion next time. So yes, we will. Okay, wait. Let's just solve this one too, and then we'll take a photo. It's early anyway. Wait, sit down. Okay. So you're calling f here. You're going here. You're making a variable. You're creating a function. You're calling this function, which returns a 9. So this turns into a 9. And then you're console logging b. What is b in the scope? Huh? What? Did I answer your question? Let's take a photo.